Ciao, my name is Filippo Martinoni, and in this tutorial I will explain you how to use Bush. Bush is the GUI, the user interface, in order to communicate with the now. So first of all, we are in Eclipse. In Eclipse, when we compile the code, we generate two files, so at least two executable. One is simrobot that I already showed, and the second one is Bush. So first of all, we have to set up in Eclipse how to reach this file. So we go, because now under run configuration we just have simrobot that we set previously. So we go under run configuration, we double click on it, we create a new launch. Now we can change the name. In our case, this would be our Bush. We have to search where is the C++ application, so we make browser. We go under, so in my case, we have here the Z-Knipser. Then we go under build. We should have Bush, Linux, develop, and here we should have, here is not possible to see it, Bush. Okay, so here is set, argument we don't need any argument, environment we don't need nothing, but common we want to have it under run at least. So we can make apply, and we can make also run. Now what happened? We can go here and we can run Bush. So as you can see on this guy, we have the different player. So in the Z-Knipser, every robot has his own name, and this is the ID of his IP. So as you can say, for every robot we can have a VLAN connection or a LAN connection. If you want to connect with the robot via cable, please ask in advance which internet port you have to use it, because if you use the wrong one, you could take away the internet from the whole room, G666, and this is not the best. I mean, it happened to us, and this was quite uncomfortable to be here and try to work without internet. Also because if you use Git and you push all the commit on the server, then you cannot download them anymore. So please, if you want to boot via to connect via cable, ask to an assistant how to do that. Else, in our case, we are going to do that via wireless. So we can go here on the internet, and we select network direct static. Now we are connected. So I will start a neo, and then so I turn on Turing. As you can see now, we have the VLAN that work, so that we are connected with Turing via VLAN. The LAN, so it's not connected via LAN. So here you have it is full when it's not connected, it is empty when it is connected. As I told you before, once more you have to be connected to network direct static. If the connection doesn't work, just have a look on the cable between the different router, if every cable is attached to them, or maybe one come out. This could happen. So now here in Turing we can select the role that we want to give to Turing, color of the team. Here we can choose other option and so on. For example, like the VLAN protocol that we want to use. We can ping it. So this means just I can select Turing and then say, okay, are you available? No, sorry, now I pressed the wrong stuff. Ping mean just I'm ask you if he's connected with me. As you can see now, he told me is available. I can download the code of the role that I select. So in this case, I select striker. So if I press here, it will deploy the striker code on Turin. Then we can restart human. This we always have to do that. So we like restart, reboot the robot. And what is interesting is if we press sim robot. So if we now press here, it will open sim robot, but it's a special version of sim robot where we can actually interact with the robot. So for example, this is the image of the camera that come from the robot. So if you can, for example, tell the robot to stand up, to sit down, to simulate the chest button that the robot have. So let's say that we want that robot stay up. I can press it and the robot fall down. Just a second. Sorry about that. Every time that you say to the robot stand up, maybe you stay behind the robot because it will probably fall down. Now we are looking on the down camera because here we see the feet. We can, but with the right click, change the camera. As you can see, for example, this should be the middle line of the field, but the field now is yellow, it's not green. This means that we should perform some color calibration. We can do that, so we can, for example, select the green. Now we should just see the green value, and according to how we change that, as you can see, we can so calibrate the color. If the color are not calibrated, the robot is not able to find himself, to locate himself inside the field, and it's not possible for him to see the ball. So we can calibrate the color, and especially if you do a perception task, here somehow I think, but I didn't do that, so it's just a guess. You can also draw all the bug driving on the image in order to see if you can do the right future extraction or something like that. But this would be better if you ask to your assistant scientist. I'm not expert on that. You could also somehow move the head of the robot. I don't know. Maybe this one. No, okay. Maybe this one. So I don't know, but whoever there is the command in order to make the robot that move along the head. And I think here you can also give some image or say, okay, now let's make a video. So save the video, say what you see, so that we can then, in order to test our algorithm, just debug and just use the recorded video and not every time turn on the robot and use it. That could be very comfortable. There are other functionality, but since I didn't work a lot with the robot, so I just work more on the simulator, I'm not able to give you more explanation. So as I say, just ask to your assistant that I'm sure he will be able to give you a better overview on that. But in order to have the basis, I think this should be enough. So thank you for your attention and see you in next tutorial.